Hi, my name is Nagdil, Application Scientist at Spectrodyne. This video will help you to identify the condition in which the particle concentration in the sample is too high. We will help you to recognize the symptoms in the raw data so you can quickly make the necessary adjustments to your sample preparation to ensure accurate size and concentration measurements. First, let's review what a typical good raw data looks like before we get into recognizing the signs of a bad acquisition run. A good quality data should have a smooth baseline with particle event appearing as a downward spike. The downward spike should be symmetrical and fully resolved from one another. We have a video on this topic on our website if you would like to gain more insights on how to understand the raw data. Next, I will show you the signs to watch out for to assess whether your sample is too highly concentrated for the measurement. For this example, I have prepared a sample of standard polystyrene beads at a concentration slightly above the upper concentration limit for the C2000 cartridge. In this case, the upper limit is 5 × 10⁹ particles per mil, and the concentration for the sample is roughly 1 × 10⁻10 particles per mil. Let's look at how significantly high concentration will manifest in the measurement run and raw data. There might be frequent clocking events shown by red axis in the raw data. The red axis are based on a rough algorithm designed to detect problem points in the signal. If the raw data looks smooth without too many clocking events or red axis, the measurement result may not be precise due to coincidence error. This is where two or more particles are present in the sensing zone at the same time, resulting in multiple particles being detected as one particle. We can look for coincidences by checking for overlapping peaks such as doublets or multiplets in the baseline, or it can also manifest as asymmetric peak. There might be a situation where you see a decrease in the frequency of particle transit events over time. This is the result of the sample clogging up the input filters, preventing further particles from being detected downstream. Another symptom that can confirm the presence of excess particle concentration is the unusually high noise floor for the cartridge class. I have here one such example. The data is from a C400 cartridge measurement. From the transit time scatter plot, we can see populations of red and green dots. The red dots are real particle events, while the green dots represent the estimated noise of false positive events in the data. Because it's a C400 cartridge, we expect the noise to be about 65 nanometers, but it's clearly not the case here. The noise has increased to upward of 100 nanometers. Notice a considerable amount of real particles events near the noise population. A substantial number of small particles near the size limit for the cartridge can cause the overall increase in the background noise. So what can you do when you find that your sample is too highly concentrated? Well, there are two steps you can take. The best method is to dilute your sample further to ensure accurate concentration measurement. If the raw data indicators mentioned above are not present in a significant degree, you might be able to salvage the data. For example, the first few minutes of the acquisition could yield good enough data before significant congestion of the input filters can occur. And that concludes a look into high concentration data analysis. Please visit our website for more training videos. Please contact us at support@spectrodynelec.com if you have any questions. Thank you for watching.